Let us consider a body on a rough horizontal surface as shown. Let us assume that the body is having a mass m and we are trying to move the body by applying a force F. As we have applied the force, we know the static frictional force comes into the picture against the relative motion and it is in the opposite direction. And we know quite well that the static frictional force is a self-adjusting force. So, until the applied force is less than Fs maximum, which is also called as limiting frictional force, the body will be always in the state of rest. We know the value of that. What is that? Fs maximum is mu s into normal reaction. In this case, the upper body applies a weight on the lower surface, hence the normal reaction is the force applied by the lower surface on the upper body, who is equal to the weight of the body itself. That means until F applied force is less than coefficient of static friction and mg, body will be in the state of rest itself. And we know if applied force is equal to the maximum frictional force or the limiting frictional force, then the body starts motion, and the motion will be started. Body will be further in the state of motion. But now I would like to consider a situation that I have the body on the rough horizontal surface. I am applying a force that is equal to the limiting frictional force itself. As I have applied the force that is minimum required, the body starts into the state of motion. Once if the body starts into the motion, the frictional force between them is no more static frictional force. It is going to be a kinetic frictional force. Therefore, I can say the kinetic frictional force is acting in the opposite direction. But we know as there is no that much of the scope for interlocking in the case of the kinetic frictional force, kinetic frictional force can be written like mu k into normal reaction, that is mu k into mg, but it is bit less than that of the static frictional force. Therefore, as the applied force is more than that of the kinetic frictional force, body will be in the state of motion. Then I can say F resultant is nothing but equal to F applied minus F kinetic frictional force. We can write F resultant as MA. F applied is nothing but the maximum static frictional force and F kinetic is this. We can cancel all the masses and we can say acceleration equal to mu s minus mu k into g. This is the acceleration acquired by a body, and we need to use this only when we have applied a minimum required force which is equal to the limiting frictional force, and we will be continuing applying the same force even after the body comes into the motion.